integral calculus, or we call it integration. Alright, from our previous classes, let's suppose we have a function y, which is a function of x. We've established that the gradient m is the y dx. So we can say if the y dx is the gradient m. From here we can also say that our dy equals to m dx. So this dy means a little change in y. So if you have to add up a little change in y, we get the what? The bigger value of y. So that's what we call integration. And this is symbol for it. If we integrate dy, this gradient, let's say is constant. So we integrate the x. So from here, our y becomes m integral x. Integration is like the reverse of what? Differentiation. From the function, we get a gradient. Now, from the gradient, we want to get the function. For example, if you recall, if y equals to ax raised to power n, we establish, or we've already established using first principle, that dy dx equals to an x raised to power n minus 1. That is what? The gradient. So how do we get the value of y? From here, to get the value of y, we have to integrate. We integrate an x raised to power n minus 1 dx, meaning with respect to x. And how do we integrate? We do the reverse of differentiation. In differentiation, what we did first is to multiply, then remove 1 from the power. This time around, we add 1 to the power, then divide by the new power. So before we did multiplication, subtraction. This time around, we do addition and division, opposite. So from here, y becomes an x raised to power n minus 1. We are going to add 1 to this. Then we will now divide by that new power, n minus 1 plus 1. Then from here, our y becomes an x raised to power what? N, because 1 minus 1 is what? 0. Over 1 minus 1 is 0 over n. From here, n cancels n, then y becomes what? Ax raised to power n. So integration is the reverse of differentiation. But the thing is, after integrating, most times you might need to put what? Plus c. Why? For example, let's suppose we have y equals to 2x cubed plus 5. Obviously, from here, dy dx, if you differentiate to what? 3 times 2, 6s squared. Now let's integrate. To integrate, y equals to what? The integral of 6s squared dx. That's how we integrate to get y. From here, y becomes, add 1 to the power, we add 6s squared, right? We add 1 to the power, then divide by the new power. Then from here, y becomes 6s cubed over 3. Then from here, y becomes what? 2s cubed. Now there's a problem here. Where is the 5? In integration, after integrating, the constant will always be lost. There is no how we can recall the constant unless we are given initial values. So after integrating, most times you write what? Plus c. After integrating, you write what? Plus c. Due to that constant, that cannot be what? Found, except if you are given extra condition. Now consider this question from UTME 1995, question 40. Two variables x and y are such that dy dx is 4x minus 3 and y is 5 when x is 2. Find y in terms of x. It means we are looking for the function itself. So what are you going to do here? This implies that dy equals to 4x minus 3 dx. To get y, we need to integrate. So from here, y becomes the integral of 4x minus 3 with respect to x. So what are you going to do from here? Y becomes, we have invisible 1 here. If you add 1 to 1, you get 2. So that's 4s squared over the new power. Then beside 3, There's nothing there actually, but we can still write x raised to power 0 there. So add 1 to 0 divided by what? 0 plus 1. So that becomes 3x raised to power 1 over 1, and that's 3x. Meaning if we integrate a constant, it becomes what? If you integrate 3, it becomes 3x. If you integrate 4, it becomes 4x. So meaning this minus 3 becomes what? Minus 3x. They won't stop here. After integrating, I told you, always put what? Plus c. For us to be able to get the value of c, that is why we are given this condition. Now, when and y is 5 when x is 2. Y is 5. We've not simplified. Let's simplify further. Y becomes 2 in 4 is, that's what? 2x squared minus 3x plus c. So we are told that y is 5 when x is 2. 2 into 2 squared minus 3 into 2 plus c. From here, 5 equals to 2 squared 4 times 2, 8 minus 6 plus 2 plus c rather. 8 minus 6 is 2. 5 minus 2 is 3. So therefore 3 is 6 is what? C is what? 3. Do not come back here. You come back here and replace the value of c with 3. So it means y equals to 2x squared minus 3x plus 3. This is what? The relation between, or this is what? Y in terms of x. The original function. So meaning we can only get the value of c if we are given the condition. Sometimes it can be initial condition. Sometimes to confuse you, the question can be manipulated or twisted in a way to confuse you, but do not panic. Look at this. A function f of x passes through the origin. When you hear the word passes through the origin, suppose this graph, and let's suppose this is function. When a function passes through the origin, it means at this origin, when y is 0, x is also 0. So that's initial condition. They are given condition. So let's continue. If its first derivative is 3x plus 2, what is first derivative? That is the y dx. But if we are told second derivative, that will be what? The 2y dx squared. But for first derivative, it is the y dx equals to 3x squared plus 2. So you are looking for f of x. So here we assume our y is the what? F of x. So let's get the value of y. From here it implies that the y equals to 3x plus 2 dx. Integrate. So y becomes the integral of 3x plus 2 dx. From here y becomes, we have 1 here, 1 plus 1, 2. Then that was 3x squared over 2. Then if you integrate a constant like 2, it becomes what? 2x. Then plus c always. Then we are told that, it passes to the origin. So it means when x is 0, y is 0. So if you put 0 here, and y is also 0, definitely c will also be 0. You can try it. This is when x is 0, y is 0. So y is 0 when x is 0. From there, 0 equals to 0 plus c. So 0 equals to c. So in that case, if c is 0, it implies that y equals to what? 3 over 2x squared plus 2x. So therefore, it means the function f of x is what? 3 over 2x squared plus 2x. In this case, the constant is what? 0. Now, consider this question. Ice forms on a refrigerator ice box at the rate of 4 minus 0.60 grams per minute. So this is what? The rate at which mass of what? Ice is formed on the ice box. So let's the mass of what? The I be m. So it means the m dt is the rate at which the mass formed on it increases. And it's given to be what? 4 minus 0.60 grams per minute. Grams per minute. So from here, let's look for, from here it means the m equals to 4 minus 0.60 dt. Let's integrate. From here, if you integrate the m, you get m. So the mass becomes the integral of 4 minus 0.60 dt. From here, m becomes, if you integrate a constant, it becomes what? 4, in this case, t. Minus, there's invisible one here, 1 plus 1, 2. That is 0.6 t squared over 2, then plus what? C. So it means the mass equals to 40 minus 0.3 t squared plus c. This is the connection between the mass and time. If initial condition, if initially there are 2 grams of ice in the box, When I say initially, it means at the beginning of time. When I say initially, it means the time is 0. This is what we call initial value. When time is 0, what's the condition? If initially there are 2 grams of fire, it means when the time is 0, when t is 0, the mass is what? 2 grams. So yeah, 2 equals to 4 into 0 minus 0.3 into 0 squared plus c. Everything here is 0. So here we are indirectly giving the value of c to be 2. So with that, we can write our m to be equals to 40 minus 0.3 t squared plus what's now c? 2. Then we cannot go on. Find the mass of the ice in 5 minutes. If t is now 5, look for m. So m becomes what? 4 into 5 minus 0.3 into 5 squared plus 2. Do this yourself and you get the final answer to be. So for the previous question, the answer is 14.5 grams. 14.5 grams. Now, next question. A student blows a balloon and its volume increases at a rate of this. Volume increases, that's what? The V, the T. At the rate of what? Pi 20 minus T squared. Centimeter cube per second after 30 seconds. What should we do here straight? The V, or directly, V becomes the integral of what? Pi 20 minus T squared dt. No, this pi is a constant, so we can bring it out. Volume becomes pi into 20 minus T squared dt. So what will be the volume here? Pi remains outside. When you integrate the constant, it becomes what? 20t minus t cube over 3. Okay, plus c. Thanks. Plus c. But we are not told. If the initial volume is 0, it means when time was 0, the volume 2 was 0. So if t is 0 here and this 0, everything here becomes 0. 0 times pi is 0. So if initially when time is 0, volume is also 0. So it means c is also 0. So in this case, our volume becomes pi 20t minus t cube over 3. So find the volume of the balloon after 2 seconds. So replace t with 2. That is 20 times 2 minus 2 cube over 3. So the volume becomes pi into 40 minus 8 over 3. 3 times 40, 120. 120 minus 8 is 112. So the volume becomes what? 112 pi over 3. Now, let us consider this question. So you may be thinking that, oh, similar to calculus, differential calculus, quotient rule. Note, there is no quotient rule in integration, but we can manipulate. But in this case, this is very simple, and these are the nature of quotient they will give you for JAMB. They will give you a fraction that you can split. For example, before you even start, we can write this one as 2x cubed over x plus 2x over x. So if we have a situation like this, it's very simple. From there, let's say the function is okay. Alright, this becomes, we are integrating. So x cubed over x, that's 2x squared plus what? Plus 2 dx. So now let's integrate. What will be the answer? 2 plus 1, 3. That is 2x cubed over 3. For 2, that's just 2x plus constant c, or sometimes you can use k. For the same thing we are doing, we want to integrate x squared minus root x over x. This is as integration of what? X squared minus x raised to power half. Indices with respect to what? X. From here, this becomes what? Integral of x squared over x minus x raised to power half over x raised to power 1 dx. And this becomes the integral of 2 minus 1, that is x raised to power 1, minus half minus 1 minus half x raised to power minus half dx. We've not started, we only simplify so that it becomes this form. What next? We cannot integrate. So the answer becomes add 1 to the power x squared divided by a new power over 2 minus add 1 to the power. When you add 1 to half, the answer becomes half. That's x raised to power half divided by what? Half. Divide by half actually means multiplying by 2. For example, if I ask you, divide 100 by half, most of them say 50. No. When you divide 100 by half, the answer is 200. Divide by half, same thing as what? Multiply by 2. So here, this becomes, I write it as half s squared minus, if you divide it by half, it becomes what? 2x power half. Now in the question, we have square root, so we can try to, write the answer in form of that. That's half s squared minus 2 root x. Because x raised to power half means what? Root x. Law of indices. Then, okay, with the constant, plus c. So far, all the examples we're dealing with are, related to a polynomial function. Now, before we go to other functions, let's take one of the application of integration, which is what? Area under curve. Now, before we move to integration, let's do a brief revision. Suppose you have a normal graph of y against x. If we want to get the area of this graph, or area under this graph from this point to this point, what are we going to do? We will multiply. No, this is a rectangle triangle. So we say the area is half base, which is what? Change in x, times total height here, which is y. So that's what? Y times what? Half of what? Change in x. So in short, to get the area, we are multiplying y by what? The corresponding what? Change in x under the curve. So in this case, it's a straight line, not a curve. We are going to apply same idea here. For integration, the area under a curve is given as the integral of y change in x. Suppose we have a curve of this form. So we want to get the area of this curve from, let's say, when x is between this number and this. So when we trace onto the curve here and we trace onto the curve here, our aim is to get the area of this shape here. But this is not a trapezium because this is not a straight line, it's a curve. So that's where integration comes in. If this were to be a straight line, we can just use area of trapezium. But because it's not a straight line, we are not going to do just normal multiplication. In this case, we integrate over little stripes. Over little stripes. So that is why the area it equals to integral of what? Function on the x. In this case, we are doing with respect to x. We can also get the area with respect to y. But most times, we do our area with respect to x. So in this case, we are taking it from this region to this region. So this is the limits within the graph where we want to get what? The area. So we can call this place A, we can call this B. So we are looking for the area of the function between what? A and B. B is the upper limit, A is the lower limit. So that's what? From between A and B, once we get the area of this shape. Let's just take one example. Let's take an example where we are going to apply this. So youth Emmy 1999 about 39. Now look at this question. Find the area bounded by the curve y. This is the curve. Between the axis, the x-axis from 0 to 2. We can do this without sketching. So in short, if you are looking for area, according to this formula, the area is the integral of y with respect to x between that boundary. And here we are given the boundary between 0 and 2. Between 0 and 2. For me, our a becomes integral of 0 to 2 of what is y? X into 2 minus x dx. From here, area becomes integral of, there's no product rule yet. In integration, there's no product rule. What you have is integration by parts, which we've not gotten there yet. So if you have something like this, you have to expand. This becomes 2x minus x squared dx. So the area becomes, from 0 to 2. We now integrate. There's missing one here, 1 plus 1, 2. That is 2s squared over 2. Minus what? 2 plus 3, 1 is 3. That's s cubed over 3. But in this case, you don't need to put the constant there. If you are given a boundary, you don't need to put the constant. But if you like, I still put it. Plus c dx. Sorry, you've already integrated, so this will not be there again. It will not be there again. Plus c. But you can just put this sign from 0 to 2. So the area becomes s squared minus s cubed over 3 plus c from 0 to 2. We are done with integration. The question is, how do we use this? Let's try to sketch the curve, for example, so we can get it better. Suppose this is sketch, it give us a maximum value, something like this. Here x is 0, here x is 2, 0, 2. So we turn this one up here. So we are looking for the area, this area, between 0 and 2. So if it's between 0 and 2, we don't need that 0 in this case. But suppose it is between, let's say, 1 and 2. In this case, what I'm going to do is, what will be the area from 0 to 0? Oh, this question, don't worry. Let's insert 2. If we insert 2 here, the area becomes 2 squared minus what? 2 cubed over 3 plus c. Minus, then we insert 0. 0 squared is 0. 0 cubed over 3 is 0, then plus c. So at the end, the area becomes 4 minus 8 over 3 plus c minus c. So that's why I said you don't need to put c, it always cancel. Whenever you are given the boundary after integrating, you don't need to put c, it always cancel. For me, the area becomes 3 times 4, 12 minus 8, that is 4 over 3 square units. So the question is, why did I put 2 here and 0 here? Then why did you subtract? Suppose we are told to look for the area between 1 and 2. If the area is between 1 and 2, so let's suppose it's 1. This is where x is 1, so we trace it here. So if it's between 1 and 2, this is what we are looking for. So we have to first look for the area between 0 and 2 by inserting 2 here. Then we now put between what, 0 and 1. Meaning we look for the area from here to here first. If we insert 2 here, we are looking for the whole area from 0 to 2. If you now insert 1, that's the area between 0 and 1. But what is desired is between 1 and 2. So we are going to subtract this from the whole so that we can get the area we are looking for. So that is why if you are given a boundary, we insert the upper limit first. Then we remove what? The lower limit from it. And that is it. Let's take another example. Some example, they may not mention area. They'll just give the integral with a boundary. Let's take another example. Look at this question. We are taught to evaluate this. In short, we actually look for the area. So just note, most times when you are given a boundary, you are looking for the area. And it will function directly. So if you have this, what are you going to do? Let's try to expand. Using square of sum, you square the first, x squared, minus twice their product. X times 1 is x times 2, that's 2x. Then plus square the second, square 1 dx. All we did is, if you have a plus b all squared in mathematics, the answer is a squared plus b squared, right? Wrong. The answer is a squared plus 2ab plus b squared. You must always add twice of the product. And this sign here is what we have here. So in this case, we cannot integrate. 2 plus 1, 3. That is what? S cubed over 3 minus 2x. There is 1 here. 1 plus 1, 2 over 2. If you integrate a constant, s comes inside, that will be what? 1x. You can just write x there. We are done with integration. Like I said, you don't need to put c there because we have the boundary. So the question is minus that is there. Note, the number is always smaller than what you have up there. So from where? From minus 2 to 1. So what are we going to do? We insert the upper limit for, which is 1. Then we have what? 1 cubed over 3 minus 2 over 2 is what? To cancel. So this is just s squared. Minus 1 squared plus 1. Minus, let's now insert minus 2. Minus 2 cubed is what? Minus 8 over 3. Minus 2 squared is 4. Then x, replace x with minus 2. Minus 1 plus 1 cancels, so everything here is 1 over 3. Minus 4 minus 2 is minus 6. 6 multiplies minus 6 will give us minus 18. Oh, let's just complete. Should not jump step. minus 6. We can bring all these 2 minus, we can factorize, and this becomes 1 over 3 plus 8 over 3 plus 6. 6 times 3, 18. 18 plus 8. 18 plus 8 is what?
24.
So from here, this becomes 27 over 3. So the answer is 9. So 9 is the area of this function between what? Minus 2 and 1. Now the thing is, we don't use integration to always get area. We can also use to get volume. Note this. When we have points joined together, we have a straight line. Straight line are usually what? The function of x when power x is 1. Then we have a quadratic form, s squared. We have cubic, s cubed. When we integrate linear, we get quadratic. When we integrate quadratic, we get what? Cubic. Linear to quadratic, quadratic to cubic. For example, if y equals to x, if dy dx equals to x, linear function, then y equals to what? S squared over 2. If we integrate further, if we integrate this, we get area. If it integrates a line, we get area. If we integrate area, we get volume. So let's talk about volume. Volume is what? Integration of area. Let's suppose y is a linear function. If we integrate y with respect to x, we get area. Volume now be what? When we integrate what? Area. We get volume. Before we move further, you can tell me this. Area is length times length. The volume is length times length times length. And from here you can say area, volume equals to 1 less than length. Area times volume. So this is y times x. But what we use actually the area equals to the integral of y with little change in x. Then volume with what? Integral of area with respect to x. But the thing is, sometimes a can be a function of what? Y. Or a can be a function of x. So if a is a function of x, then you have the x. But if a is a function of y, we are going to have the y. To understand this better, look at this. Suppose I have this function, and here what we have here is a straight line. The area under the straight line will be the area of what? The area of what? Of rectangle. Suppose this area we now have, this particular, area, this region, the whole of this. I move this point, move it back, then this 2D. If I go in and inside the board, suppose I have something like this. So let's represent this area with this. So if I bring this in and I rotate it, what are you going to get? You get a cylinder. Check again. This region is fixed, it's not moving. This one is not moving, it's fixed. Then this move this way. Then back to where it is. The shape we are going to form is going to be what? Cylinder. And in that case, we are integrating the area over a what? Change in value of x where y is fixed. Okay, what if we rotate this thing along y-axis instead? Is it a circle? It cannot be a circle. It can only be a circle if it's a straight line here. Then we'll rotate this way. But if you rotate it in z-axis, we have a straight line this way. In z-axis alone, it gives us a circle, but that circle will not be what? Straight. So in short, to get the real picture of this, volumes are gotten when we integrate area, and area are gotten when we integrate line. What do we mean by integrating a line? For example, if you choose a small value of x and dx, we add up these whole lines. When you add up lines, you get area. Then when you add up area, we get what? We get volume. Okay, for example, let's suppose we have a function of y and x, and in this case, this is what we have. If I take this point and I rotate it from here, this top I write as a circle, something like this, we'll get a cone. So if you have this straight line and it's rotated about the y-axis being fixed, we get a cone. And this length will be the slant length of the cone. Okay, another one. What if you have something like this and we rotate? We rotate this one, we are going to get an hemisphere. Okay, suppose we rotate something like this. Let's just draw a random figure. Something like this. Then we rotate it. Can you see? It's not really a shape you can talk about, but the thing is, we have, if you rotate any random line, you get a volume. So what actually happened for this one, the rotation is actually, we are rotating this area. This one also, we are rotating this area. This one we are rotating what? This area. And this time around, we are not taking the area about x-axis, we are taking about y-axis. We are taking about y-axis. So sometimes, if this area is function of x, it will be the x. If it's y, it can also be y. So meaning volume can also be integral about area dy. In this case, this a is a function of y. For this case, a is a function of x. Let's take examples. Particularly UTME questions. Now look at this question. Find the volume of a solid generated when the area enclosed by y equals 0 and y equals 2x and x equals 3 is rotated about the z-axis. Now the thing is, y equals 2x ordinarily, you don't need to learn how to sketch it before you can get it. But let me just do that for the purpose of explanation. So if y equals 2x, it means for this graph, it will be a linear graph because x is what? Has a degree of 1. And it's going to start with from the origin. Ordinarily, if we rotate this about the y-axis, it will give us what? Area of a circle. It will give us area of a circle. Sorry, it will give us a circle rather. With this giving us, in this case, this representing y is like our, what do you call it, radius. First, volume is integral of the area dx. And in this case, the area is area of a circle, which is pi r squared dx. And in this case, the radius is what? Is along the y-axis. That's pi y squared dx. But the thing is, we cannot integrate y with relation to x. They must both xx or both yy. So from here, volume becomes pi. What is y? Y is 2x. 2x all squared dx. So the volume becomes, that's pi 4. You can make the pi out as a constant. 4s squared dx. Now the next question is, what's the boundary? From between x equals to what to what? We are already told that x is 3. So this x3 right, most likely will be the upper limit. Let's now get lower limit. When y is 0, we are told between y is 0, y equals 2x, and x equals 3. Suppose this is where x equals 3. So what's the value of x here? We have to know it. And definitely it's going to be 0. Why? For this particular graph, we start from the origin. Or you can just come here and insert. What is x when y is 0? Since you are told y equals to 2x. Then when y is 0, y will be x. Obviously, x is also 0. So it means the limit will be from 0 to 2. From here, the volume becomes, now let's integrate. S squared, I want to it, that becomes s cubed. That's 4s cubed over what? 3. From 0 to 2. From here, the volume becomes pi 4. What is x? 2 cubed over 3. I told you minus pi 4 into 0 cubed plus 3. But everything here is 0, cancel. So the volume becomes pi 2 cubed is 8. 8 times 4 will give us 32 over 3. So the volume becomes 32 pi over 3. We're not given units, so that's cubic units. Cubic units. And that is the answer. Now look at this question. Before solving, let's try to make sense of it in real life. They will not solve. A bowl is designed. So a bowl is designed by revolving completely the area enclosed by this function. So let's suppose this graph of y and x. So this particular one will give us a curve with minimum value because s squared is positive. Sorry, the coefficient is positive, so it gives us minimum value, and it's going to cut y-axis as it's like that's why it's -1. Not really, but if you have to sketch this, we can have something like this, perhaps. So this is the curve. Or okay, now between when y is what 0 and 3. So suppose this is where y is 0, and this is where y is 3. So this curve between 0 and 3 is now rotated. This last thing that is rotated. It's completely, sorry, a ball is designed by revolving completely the area enclosed by this y between y is 0 and 3. So between 0 and 3, this portion. So what's the area enclosed? This is the area enclosed. And we are told that x is greater than or equal to 0. This way x is 0. So s is greater than or equal to 0. So this is the what? Area. Now this area, it is what is now rotated completely around the y-axis. So this thing here, this stripe, was rotated along the y-axis. So at the end of the day, if this is rotated around y-axis, we are going to have something like this. Sorry. So this is how the bowl look like. So this is what we rotated. So for those that work in industry where they design, the car parts, aeroplane parts, or machine parts, either phone and the likes. So they use application of what? Integration in this case. So from the function we can design, So now let's forget about design. Let's come back to JAM. Let's solve this question. In this case, the area of the shape is going to be pi. Where is in pi? Look at this. What shape is this? Circle. And what's the radius of circle here? It is horizontal. So in this case, it's going to be pi s squared. Or the radius is what? Along x, dx. And we are told that y equals to s squared minus 1. And we need s squared. From here, you can say s squared equals to y plus 1. So the area becomes the integral of what? Pi. What is now x squared? Y plus 1 dx. We replace s squared with y plus 1. But there is a problem here. Next, what is the boundary? But if you notice here, what we have here is y. Since this area is the form of y, this limit you are going to use must also be limit for y. And we are told that the limit is from where? 0 to 3. 0 to 3. 0 to 3. So pi is common. The area becomes, bring out the pi, integral from 0 to 3 of y plus 1, in this case dy. Why? Because the limit you are using is what? Y limit, so it has to be dy. So if we integrate with respect to dy, we'll be having y squared plus y. Y squared over 2 plus y from 0 to 3. Why are we doing this? Integration, this one here. 1 plus 1, 2, divided by new power. For 1, if you integrate with respect to y, it gives us y. So what's the limit from 3 to 0, or from 0 to 3? So improve the upper limit. So the area becomes, sorry, not area, rather, volume. volume. Sorry for that. Volume. So the volume becomes pi. Let's insert 3 squared over 2 plus 3. Pi 9 over 2 plus 3. 2 times 3, 6. 6 plus 9, 15. So that's what? 15 pi over 2. How the units? Then I'll give them that be what? Cubic units. And that's the final answer. So in summary, I know you might be confused with this example and the previous one. Note that if we are integrating with respect to x, then here, if you are using limit of the x, then this will be s squared. But I would like to stop the class here. So in our next class, we'll do more of this, and particularly, we are going to look into other forms of other function. We'll be looking through polynomial function all this while. So we are going to look into trig function, exponential function, logarithmic function, and others. See you in my next class.